mine. I've got all this workshop space. The first time in 5 years being able to run around in circles. I've got loads of space, I've got loads of space. The subject of today's video is all the way over there, if you can see it. It's in the corner, that little blue box. Let's go and take a closer look. I've got a fabrication job on here. What I need to do is I need to make a square hole in this 3mm thick piece of steel. Well, it's actually 3.5mm. I've got two pieces. They both need a square hole putting in, and they got to be big enough to be able to pass this piece of box section through. This box section is going to have a leg welded on underneath, and then this bracket here will pass over the top, so through the hole all the way down to the leg, to stop this leg from rising up. I won't go into all the details of what I'm making because that's not really the point of what I'm showing you. The point of what I'm showing you is just the fact that I'm going to crack open the little handheld plasma cutter and show you how it works. So I thought to myself, how am I going to make a square hole in this? It's going to be real hassle. I'm going to have to get the drill out, drill, you know, a series of holes, then knock it out and then file it all out. And that's the traditional way I would have done this. Of course I could have used like a cut-off saw or something, but then you end up invariably overrunning the edges, so you end up with sort of slits or deep grooves in the plate. I just want a clean square hole in this. I'll just run through the setup sequence very quickly. First of all, you need to fit the mains plug. The torch for the unit comes pre-assembled. All you have to do is screw in the main power cable and the switch cable. This is the workpiece cable, or the earth cable. It comes complete with a clamp already bolted to the end. The other end couldn't be any more simple. It's just a simple bayonet fitting, and this bayonet fitting just goes straight into the unit like that, and that's as hard as it gets. It needs an air supply, so I've got my airline attached to the back. So I've turned the air off at the trap and gauge because we've got the potential of 120 psi at the airline. I'm running it pretty much flat out. Now you only need 50 psi at the torch, so I've turned it all the way off, turned the machine on, machine's powered up straight away. Then I've turned it up until I've got practically 50 psi, it says, on the gauge. Then you can do a gas test. So you test the gas and then that needle flicks down. When it flicks down, I've just adjusted it up to get it back up to 50 psi when it's running, because you need around 50 psi when it's running. And then the power's there. Just literally turn the power up and down. Have the torch, select on cutting. Now it says in the booklet you want to go for around about 20 amps if you're cutting 6mm steel, or 30 amps if you're cutting 12. 12, yes, can you believe it, 12mm. Now apparently it will do an 8mm cut straight through, or up to 12mm severance cut. So basically the torch will be coming in from the edge. So you're cutting through at an angle, or you raise the torch up and then drive the torch down into the material. That's basically what they mean by a severance cut. Or you can just hold the torch up against a piece of metal and it should be able to just blast straight through 8mm of steel, which I find pretty incredible really. I have just tried it out. I just plugged it in and tried it out. I'll show you what I did. This is just a bit of scrap metal, and you can see how neat the cut is. Of course it's freehand, so wherever your hand goes, that's where the cut's going to go. So what I'm going to do is I'm going to grip a piece of flat metal to my piece that I'm going to cut a square hole in to act as a guide, so I can get straighter cuts in the metal. And this is just thin, this is just very thin stuff at the power turn right down. I just wanted to see it actually work before I turn it on the thing that I want to cut. So happy with that. I'm happy with the settings. So I just need to rig something up so that I'm cutting completely downwards, and then I'll see if I can cut a square hole in this piece of metal. I'll give it a clean up first as well. I've just found out some more steel. This is 3.2mm thick, so I'm going to scribe around this You know, with a torch it's going to be slightly larger because of the thickness of the torch end, but that doesn't really matter because it's not an engineering job. I just want to make a duplicate of the top one. I'm going to run the machine at, I've got it set to 20, I'm going to just start at 20 amps, so I've got it set to 20 amps. Nice long cable as well, so you can get the workpiece a long way away from the machine where it's showering everything with sparks. I got some boots on, leather boots, flame-proof overalls and some leather gloves as well. Something else you really need to do is protect your eyes when you're plasma cutting, so you could wear a good old-fashioned set of goggles like this that's used for gas welding. That's what I use these for. What I'm going to use is my new mask, because this mask, not only is it for welding, it's also for cutting and grinding. I'll just show you some of the settings that it's got. So what would be pretty standard to any welding mask that you would buy would be from shade, certainly down to shade number 9. But what you have got on this, you see, is you've got further decreasing shades. So if I change the mode over to cut, then it goes down to 8 to 5. And then you've got a grinding shade, which is shade number 4. Now, what you can do, I believe, is if you were doing some very, very low amperage welding, we're talking very, very low here, but if you were, then you could use the shade number 8 if the 9 was too dark. Obviously, you've got to be extremely careful with what you're doing here. You really don't want to damage your eyes, but there is that sort of facility with this mask. Certainly need to think about wearing a respirator, particularly if you haven't got fantastic ventilation in your workshop, because when you're cutting you're producing the same kind of fumes that you will be if you were welding. Now, I've actually got an extractor in my workshop that probably changes the air a couple of times every minute in the room, so it's pretty efficient at changing the air over. But if you haven't got a great extractor or no extractor at all, then you definitely need to be wearing some kind of fume respirator. Okay, so this was the result from the first hole that I cut. and I wasn't really very happy with the results, to be quite honest with you. What I used was a flat piece of bar, and then I used that as a guide for the torch to follow it round. I think what happens is, because you're going straight in, initially there's quite a lot of sparks and splatter that flies out, and that flies out, and I think that's stuck to the flat bar that I was using, the guide. So it sort of flies out, and then because you're dragging the torch along the bar, then it has to negotiate that splatter that's all up the side of the bar and sends you off course slightly. Anyway, I mean, this is good enough for what I wanted anyway, because basically I just wanted a squarish hole in a piece of metal. This will actually do. I'll still use this, it's not a problem, that'll be absolutely fine, because what I need to do, you see, is I need to have square hole, flat plate of metal, and it's got to be slightly larger than this leg. Now this leg's going to have a foot on the end of it, just basically a piece of flat bar, a wide piece of flat bar, and then this slides over the top and pins the foot down. So there's weight on top of this, and that stops that leg from rising up. That's all it is. It's not like a, you know, a high tolerance engineering job. This is basically all I wanted. So what I did on the second one anyway, I thought, well, the thing to do is surely is just to make it slightly smaller and then file it out larger to try and get rid of the imperfections. So I tried to make a nicer job of the second one, and what I did is I forgot the guide, and I literally just got my piece of box section, held it like that, drew around with a Sharpie, and then just took my time cutting it around freehand, and made a pretty good job of it freehand. Actually, it wasn't so bad at all. I found that if I just held the torch slightly off the steel, slightly just above it, so that it wasn't dragging along the steel, I could just draw it around, really taking my time. And the Sharpie line was really easy, really visible to see, so I could just follow that Sharpie line. Of course, you've got like quite a crust coming off the cut underneath particularly. I was quite alarmed at that to start with. I thought, wow, I'm going to be in for some pretty heavy cleaning up here with the angle grinder, but no. A few taps with the end of my panel hammer, and that crust just fell straight off and leaves quite a crisp edge. Actually, it's quite clean. Of course, depending on what you were going to do, I mean, if you were just making up rough and ready brackets, you could just chip the crust off, get your welder out and start welding it. You know, if you were making a bracket or whatever, if you're making up a gate or something like that that doesn't need to be that accurate or that clean, then that would be plenty good enough, I would thought. So I'm happy with that anyway, very happy. And I literally just chipped that crust out from around there, and then I got my little finger file in. I probably spent a whole minute and a half just going around, just squaring that hole up. I'm really pleased with how clean that's come out. And I just got my angle grinder with my flat disc and just went around the edges just to clean the edges up. They didn't really need a lot of cleaning up, to be honest with you. And yeah, very pleased with that. It's come out better than I expected, and with a little bit of practice I think that's going to become a very useful tool. So changing the torch consumables. The consumables do wear out and will need changing from time to time. It's an exceptionally easy task just to swap them over, and you get a large pack of consumables with the cutter. So let's put this cutter through its paces and cut some thicker materials, just see what it's capable of. So I'm cutting some 8mm steel here. Here I am cutting a circular hole in an 8mm piece of steel using an engine hoist die as a guide. So let's see what this thing can actually cut. 10mm, no problem at all. So I thought, well, let's just do as much as I can, and I managed to get it to cut nearly 15mm. I also used a piece of box section to try and create a nice straight cut. This ran nicely up against the ceramic cup on the end, and I managed to get a real nice straight cut. So how does this plasma cutter cut straight through steel? Well, in basic terms, it's generating a super hot channel of gas that can cut straight through steel. This gas is referred to as plasma, because that's what it is, plasma gas coming out the end. Plasma gas is basically ionized gas. So ions are basically atoms. So you've got an atom and you've got electrons whizzing around the outside, remove some of those electrons, and then you've got an ion. So ionized gas can be created, so you've got the gas coming out the end, which is compressed air, could be using oxygen or an inert gas as well. So you've got that whizzing around the electrode and coming out the end. So you've got this scenario. You've got a lot of electrical energy there, and when an arc is produced, that arc produces the superheated ionized gas that comes out the little point in the end and blows straight through the steel, because the ionized gas is so hot. And that's basically how it works. Now this has got high frequency starter on it, so it means that as soon as you hold it up against the workpiece, high frequency is lots and lots of voltage but hardly any amperage, and what this means is it can jump a large gap which sets up the arc. So you get the high frequency start, so that jumps straight to the workpiece because the workpiece is earthed, creating the circuit. So we've got a circuit going on, because that's basically all we're doing is generating a completed circuit. So the high frequency spark starts, and then the amperage comes in behind, so then it arcs out inside the torch, creating this incredibly hot gas, which is so hot that it melts straight through steel. Before I wrap this up, I'd like to say a few things, and I've also got a bit of news about something else that I'm working on that's coming up. So why buy this when you can buy something a lot cheaper? I know somebody's going to say that in the comment section, and to be honest with you, I kind of understand what you're saying in a way. I mean, we all like our own little things, don't we? I mean, me like chicken, me like punani. So if you're just viewing a plasma cutter as a box that you plug into the mains and the airline and it cuts through steel, then yes, they'll all do that. And some of the cheapo ones work quite well too. But there are some very important differences to consider when you're thinking about buying a plasma cutter. If it's something you're just going to use once or twice ever and not push it really hard, and you don't mind it going bang, then by all means just invest in a cheap and cheerful one. But like I was saying, there's some interesting and different things going on inside these units, which makes the difference, and makes all the difference as well. So this one's got a 35% duty cycle running flat out, I hasten to add, which means that duty cycle, you take a 10-minute time slot, so 35% of 10 minutes is 3.5 minutes. So this machine will run for 3.5 minutes absolutely flat out, which is a long time. And what it'll do is it will overheat, but there's thermal protection built into the unit, so it'll shut it down before it damages any of the vital components inside, which something else may not have, I don't know. But like I said, 35% running flat out. Now at 20 amps, it's got 100% duty cycle, which means in real terms, if you're not cutting really thick stuff, this could be the unit for you, because you're never going to be pushing it that hard. If you occasionally need to cut something that's, you know, if you're going to be wanting to cut 10mm stuff, say, all day long, then this isn't the machine for you. What you need to be doing is looking at the 50 amp model. Just so happens, my mate Jason, Make It Metal, on YouTube, did a review on a 50 amper, and that was cutting some pretty thick stuff. What I'll do is I'll stick a link in the video description so you can watch Jason's review, because he gives you a pretty good rundown on that unit, and you can go and see that and think about what you actually need. So think about your requirements. If you're going to be cutting thinner stuff, you know, sort of 3mm, 6mm stuff, this thing is going to do it all day long, no problem at all. And like I say, at 20 amps, at just 20 amps, it's got a 100% duty cycle, so it's not going to overheat. So one of the final and very important considerations I'd make is to do with the inverter technology, because this is an inverter welder. Now, the old welders were analog, and they were very big and they were very heavy, and these inverter machines are far more compact and far lighter than the old analog machines would have been. Now, they create the power by using electronics rather than just, you know, a huge great big transformer. The other point as well is it means that the power setting is variable as well, rather than a great big stepped switch on the front. So there are two different types of transistors that are used in the inverter side of things. So you've got a MOSFET type transistor, which is a metal oxide semiconductor field effect transistor. Now, those transistors, as far as I'm aware, were like the first ones to be kind of produced. Things have moved along since then, but the cost of those is very, very cheap. Now, this is an IGBT model, which is an insulated gate bipolar transistor, and this is far superior to the MOSFET. Now, the MOSFET being a much cheaper transistor to produce, of course, that's what they jam in the cheap ones. So just bear all this in mind when you're thinking about buying something, or you're thinking about the cost. It's not just a box that plugs into the mains and the airline. There's far more to it than just that. Perhaps the final consideration really should have been about the Artec warranty, because of course if anything goes wrong in the first 3 years of you buying it, they'll collect it, they'll fix it, and they'll deliver it back to you free of charge, provided you live in the UK. So that's something really worth sort of thinking about. Anyway, I'd just like to say briefly, I don't work for Artec, and take all of the things I've said on board. I may have made the odd little mistake in there somewhere, so just check it out for yourself. Just make sure that I've got all those points absolutely, you know, spot on before you just go taking my word for it 100%. But you know, this is me, as always, from the heart, you know, and I may get the odd thing wrong. Anyway, before I go, yeah, I've got an interesting little project coming up, because I've been wanting to make a press for ages, and I don't mean like a bearing press. I mean a press for fabricating my own panels, not huge panels, but just sort of small repair sections. Actually, I'm getting carried away. I won't go into it anymore, because this is going to be a conversation for a future video. Anyway, I was having a chat to Rob from Xtreme Engineering, and he said that he just had his beams moved inside his workshop, because he's got these RSJs that are right in the centre of the workshop, so he's had to move to the outside braced so that he can get more machinery in there, make better use of the space that he's got. I said to him, did you keep the old beams, because I want to make this press? And he said, no, I haven't got them. But what do you need? What are you after? And I told him the situation. And then he phoned me up and he said, Trev, I'm stood at the steel stockholders and I'm looking at some RSJs. What do you want? He put me on the spot a little bit, because I hadn't really considered the exact sizings I needed, but we sort of thrashed out very quickly what he needed, and he rang me back sort of, I don't know, about an hour later. He said, Trev, the stuff's ready, come and pick it up, just like that. So thanks very much, Rob. Let's go and have a look at these let's go and have a look at these beams, and I'll sort of talk you through what my thoughts and ideas are. Here are the steel RSJs. Now, when I had a chat to Rob, I kind of guessed that around 1 metre would have been about the appropriate size. Well, it just so happened that these are offcuts. So these are offcuts. They had a few of the offcuts, and the offcuts sawn in half were going to be around about 900mm. So, you know, pretty much spot on the kind of size I was looking for. So what we're looking at is about 89 centimeters, which is just off 3 foot. and so that's 5 inches 13 centimeters, or 3 inches 8 centimeters that way. So yeah, they're not absolutely massive, but they will hold an enormous weight, I would have thought. I didn't want it too big because obviously I'm very limited for space, and the larger you make the frame, the more impact a load is going to have on it over a span. So you make a very short span and it can take a lot more weight than a long span, if you know what I'm trying to say. So what I intend to do is, with the plasma cutter, cut out the webbing part of the RSJ. So cut it round exactly the same shape as that, so I can sharpie around there, then cut it out afterwards, post the RSJ through that slot, and then weld it round in the webbing, and then make some bridging parts to go from there to there, so that it ties everything in nicely. I may or may not knock a hole in the webbing here, so that I can actually pass something long that I want to press out, so it could go all the way through, extending the width of the press. The other thing I could do is I could turn it around the other way, so I could actually have a bed going in this direction, extending it that way. So I could do that rather than knocking the hole down there. Like I say, it's just all up in the air at the moment, but this is kind of the way I want to weld the frame up. The frame won't be used in this orientation, it'll be used 90 degrees round. I've just stood it up like that just to show you, because of course it won't stack the other way. And the basic idea is you put a ram or a jack or something on there, and you press against that side, and you've got an enormously strong rigid frame to press off. Now, I mean, this is a 2-ton bottle jack. You probably actually do quite a lot with this, but what I have got is I've got a 10-ton ram, and it's got an air operated hydraulic pump somewhere. I mean, I haven't seen this stuff probably for nearly a decade now, so I'm going to have to go through all my stuff and dig it out and make sure it all works. But I'm hoping that the ram will fit in this frame. See, it's quite a big ram, so I don't know whether this frame's actually going to be wide enough. If it's too long, the ram, what I could do is I could just get a larger bottle jack, because you can get bottle jacks, I mean, I've seen them 20 tons. You can actually get 20-ton bottle jack. But this ram I've got is 10 tons, which will be probably more than enough for what I want to do. Some success! I found the ram. It didn't take me long to find either. So this is the 10-ton ram. Now, this is off my old body straightening kit that I used to have, and it's pretty much a perfect size. Have a good 200 millimeters or 8 inches of clearance between the end of the jack and the end of the frame. So that's going to allow me to be able to press out something quite deep, really. I mean, at the end of the day, if I need it to be any deeper, then I just have to get some longer RSJs. I have got enough. If you're a bit confused as to why I've got as many as I have got enough to double this up, because although I can make a double frame, make it exceptionally strong. I mean, if I don't make 2 frames up, this stuff ain't going to waste, because I've got so many ideas for different metal shaping equipment that I want to make, and a nice bit of strong RSJ is just what I need to be able to sort of take the force of shaping sheet metal, really. So I've got the pump connected up. So this is an air operated pump, and this just pumps the fluid. See if it and you press that back to release it. I haven't actually got very much fluid in this. I don't think there's enough in there to extend the ram fully, so I need to get some more oil And yeah, but it works anyway. First time I plugged it in probably a decade. That's working fine. That'll be all right. Definitely need some more oil in there. So yes, interesting things to come. Well worthwhile having this plasma cutter, because of course I can use it now for cutting these beams. So it will be making a future appearance very shortly. Anyway, very exciting times. I'm off. I'll say bye for now.
It's the Electric Radio Show. It's the time of the show when we turn the spotlight onto a notable, whether it's musician, artist, painter, writer, filmmaker, whoever it is. We give you props for your project, and all you got to do is just go to theelectricradioshow.com, click on the banner for the Underground Spotlight, give us all the deets. Who knows, we could be picking you. But this time around, because we've been out on the road for a month, and we're still trying to catch up on our emails. We're still trying to catch up on things. It's been busy. And we'll be back to the music on the Underground Spotlight, or author, whoever comes up next week. But this time around, you guys know I'm huge YouTuber. I watch and listen to YouTube constantly. There is a YouTuber out there. You guys heard me talk about Cameron Nemel on the show. He's the guy that basically got me into doing powder coating, and he's like the driving force that got me into Viper powder coating. There's another guy out there, and our UK affiliates, he could probably catch the show because he's in the United Kingdom. And he is like an extremely talented fabricator. He's a fabricator, and he's restored cars. He does welding tips and all this stuff on there, and I have benefited from this guy's YouTube channel more than he even knows. And I've corresponded with him through messages like on Instagram. This guy's name is Trevor Hatton, and he's got a YouTube channel out there called Trev's Blog. And if you go to that, if you're even remotely interested in restoring cars, or maybe your bike, or whatever you do in metal work, this dude lays it out completely simple for you to understand. I mean, I'm no stretch a welder I'm a certified welder, but I'm not a welder. This dude shows you how to take like just basic hand tools, make panels, do everything. Trevor is probably one of the most incredibly talented guys I've ever seen.
Wow.
The pay it forward now is he and his wife have started up a new business in the UK. Trevor restored this old Bedford van. This thing was a Hulk, and he brought this thing into a mobile catering business. And he just put in a coffee machine that looks like yours.
Oh, yeah?
At Mama Musetti's.
Wow.
And I said, I got to give this man some love. Him and his wife just started a YouTube channel for their business called The Baking Bird. And check them out on YouTube. It's The Baking Bird UK. Facebook at The Baking Bird UK. Instagram at The Baking Bird UK. I just want to give these two people my congratulations. I'm wishing you the biggest success in the United Kingdom with this, because he made a cup of coffee in the first video upload. I wanted a cup. And it was just like at Andre's place. He did the espresso, he did the foaming the foaming milk
lattes,
man. And so the same way that we advertise for each other, our business is here. I want to send my love to Trevor Hatton and his wife Tracy, wishing you all the best of luck in the world with the Baking Bird. And again, well, first off, let me give him a round of applause. Go to the Baking Bird UK on Instagram. You'll see the pictures of the Bedford that Trevor put together for this. And if you go to Trev's blog, you can see the entire metamorphosis of this project that went on in a series of YouTube videos, and he keeps his videos short. They're like 15 minutes.
That's awesome.
So they're very watchable. Trevor's a very entertaining guy. So it's Trev's blog for the restorations and fabrications. Go check him out. And the Baking Bird UK on Facebook, Instagram, and YouTube. Subscribe, like, share, and give these people some love. They absolutely deserve it. Trev's a great guy, and every time I hit him up for information, boom. I'm telling you,
That's so
halfway
cool.
around the world, man, this man hits me right back. So congratulations to Trev and
Have to
Tracy
check it
Hatton.
out.
I wish you all the best on your new venture called the Baking Bird. Coming up, now that app turns me on.
Oh, boy.
So D-Light's looking at me going, now that story is going to be dirty. She knows me well. That's coming up on the Electric Radio Show.